Hey everyone, so today we'll go over tautology and contradictions, which is a part of discrete mathematics, and more specifically within the branch of propositional logic. So first of all, let's quickly go over the definition of a tautology and a contradiction. So a tautology is a logical statement that is always true. So this part is the most important part, is that it is always true, regardless of the truth values of its variables. So meaning when we have a proposition, right? Let's say P and Q. So, we could have P or Q or P and Q. So it doesn't matter if P and Q are true or false, but this statement here or this statement is always going to be true regardless of that. So that is a tautology. So the contradiction is just a reversal of a tautology. So essentially, it's a logical statement that is always false. So then again, this is the most important factor when it comes to knowing if it's a contradiction or a tautology. That is always false, regardless of the true values of its variables. So if we take a look at this in more mathematical term, so these are the forms of the most popular and known tautology and contradictions. So for the tautology, right, we have P or not P. And remember, P is a proposition. So P is a proposition. And we know that a proposition, well, to be a proposition, it has to be either true or false, but never both at the same time. And we can know for sure it's either true or false. So when we state this guy over here, right, we have P or not P. So in that scenario, when you guys think about it, since P is either true or false, and we know that when we have an or, we only need one of them to be true for this whole statement to be true, right? So in this case, it's always going to be true. Either P is true, so P is either true or false, right? So let's take the when P is true. So if P is true, right, P or not P is still true. But let's say P is false. That means not P is true, right? So if not P is true, that means this is also true. So we can see that regardless of if P is true or not, P or not P is always going to be true. And in the same sense where we have the contradiction, right? Where it's already over here, so it's P and not P. So when we have and here, right, we need both of these propositions to be true. But we know that, for example, if P is true, that means not P is false. And in the reverse case of if not P is true, then P has to be false, right? So in these two cases, we get that this is false but in both cases. So it's always going to be false, which shows us that it's a contradiction. So if that's a bit abstract, I'll give you guys a few English examples, and I think it's going to clear up a lot of, the misunderstanding, or it's going to help you guys really understand tautologies and contradictions. So let's go over this first one over here. So I'll put them 1 to 4. So number one states that it will either rain or it won't tomorrow, right? So in this case, we can all agree that this has to be true, right? So either it's going to rain or it's not going to rain, right? It cannot maybe rain. We are going to know for sure if it's going to rain or not tomorrow. So in this case, number one would be a tautology, because regardless of what happens tomorrow, it will either rain or not rain, right? So that is true. Now let's look at number two. It states that you are under arrest, but free to go. So here, this is a contradiction because when you're under arrest, you're not free to go, right? But when you're free to go, you're not under arrest. But in this case, we're stating them together, right? You were saying that you're under arrest, but you can go. So this is never true, right? So this would be a contradiction since it's always false. So this is a contradiction. Now let's take a look at number three. The item is either in stock or out of stock. So in this case, again, we can see that this is a tautology because it will always be true. Either the item is in stock or it's out of stock, right? There's no in between. So regardless of if it's in stock or out of stock, it will be true. The statement will be true. So now let's take a look at our last example, which is number 4, which states that the car is moving at a constant speed and accelerating at the same time. So we can see here, this is a contradiction because if we are advancing, right? Contradiction. So if we are advancing at a constant speed, that implies that we are not accelerating. So when we state that we are, moving at a constant speed and accelerating at the same time, right? that should ring alarm bells because that doesn't make sense. Also, if you take the reverse situation of it, if we are accelerating, right? So if we are accelerating, we can't be going at a constant speed, right? And the reverse is also true, that if we're going at a constant speed, we cannot be accelerating. That'll be it for an introduction to tautology and contradictions, which is an important part in discrete mathematics, and I hope you guys enjoyed the video.